The days were 8 hours long, which sounds completely fine. Sounds like a normal job. Except I had just spent the last 2 years where days were 12, 14, 16 hours long, sometimes more. And somehow, those 16-hour days went faster than the 8 hours did back in the shop. I remember staring at the clock thinking, how is it only 1 p.m.? How is it only 2 p.m.? I've done everything I can think of that I need to have done today. I've reviewed the drawings, I've written notes, I've had the meetings, I've sent the emails, and it's only 1 p.m. There's a version of that story that sounds like a guy complaining about having an easy job, but that's not what it was, and that's not what this episode is about. This is about what happens when you come home from being in the field for such an extended period of time and what that actually feels like, and what you actually find out about yourself and the company that you work for when the project is finally done and you're back in the building that you work at. Welcome to From the Bucket, where controls design meets reality. I'm your host, Keely Smith. In this podcast, we explore industrial control systems as they exist in the field, not just how they were designed in CAD or how they look on paper, but how they operated in a production environment, how operators and maintenance interfaced with them, and the fun and interesting stories that I've made throughout the years of being a controls engineer. So here we are, episode 10. I genuinely didn't know where this thing was going to go when I started it. And I mean that in the best of ways, right? Everybody starts out projects with the best of intentions, and life gets in the way sometimes and whatever. But it's been such a cool journey for me, just even being 10 episodes into it. So I want to say thank you. If you've been listening since episode 1, or somehow you started somewhere in the middle, or maybe this is the first episode you've listened to, if this is the first one, it might be less make less sense to you, but genuinely thank you. The fact that there are people that are actually listening to me talk about conveyors, PLCs, hotel rooms in Dallas, me being a young dumb engineer making young dumb mistakes. I appreciate your time, and I don't take it for granted. This show really started as an idea, and I really wasn't sure that it made a whole lot of sense, but it's been fun, and it's been uh, really well received by a lot of people that I really genuinely enjoy the conversations that it has started. So, uh, with that said, we'll get right into the episode. But I just wanted to take a second and say, you know, thank you for being a listener, and here's to 10 more episodes, I guess. So Dallas is done. 2 years of travel back and forth, 2 years of working in the same facility, 2 years of building something uh, pretty incredible, multiple production lines, more hours than I had ever worked in my life. And now I'm back. And realistically, that should feel good, right? I'm home. I'm sleeping in my own bed. I'm not living out of a suitcase in a hotel anymore. You know, my fiance doesn't have to wonder, am I coming home Friday? Am I coming home Saturday? Is something going to happen? And I'm going to spend another week on site because I'm home now. And all of that is genuinely great. Like, it was so nice to be home for, I guess, the personal side of things. But being back in the shop was a different animal entirely. In a lot of ways, when you're out in the field, things are a lot simpler. The objective is really simple: get the line running, get the system running, do whatever it is that you're there on site for, get it signed off, and move on. Everything you do is pointed at that one thing, and that one thing is to get home. And you just are constantly making decisions, and they're fast, they're real time. Like, you're just rapid fire because you have that singular goal of getting things done, getting things signed off, and getting home. And the thing is that when you're making these decisions, they can be fast and they can be real time because nobody else is really making these decisions for you. You're the last line of defense. And, that was the phrase that I used back in episode 3, and I meant it then and I mean it now. Controls is really the last to touch everything, which means when something's not working, it's really your problem until it's not. And, that kind of responsibility really changes the way that you operate. And one of the biggest things that I found is it changes your pace. It changes how you think. You don't ask for permission to move a photo eye. You move the photo eye. There's none of this kind of rule by committee. It's say, I'm functionally looking at a system and I see what the problem is, and I come up with the solution to that problem. And then you come back to the shop and you suddenly go from making these real time decisions to you're talking to 3 different people, you're redlining a drawing, you're getting it reviewed by multiple people. I mean, something as simple as moving a photo eye, you could be reviewing that with the panel designer. You could be then reviewing that with the mechanical engineer. You could be reviewing it with your boss, their boss. All these different people now have to touch it, look at it, and then maybe after all of that, it gets moved. Now, one thing that I want to be very clear of very early is I'm not saying that process is wrong. And I think that there is a version of that process that makes total sense. You want that documentation, you want that consistency, and most of all, you want to make sure that the next engineer who touches this system really understands what they're looking at. And again, all of that comes with all that documentation and the approvals. But here's the thing, and this is where I struggled really badly with this is, I had just spent 2 years operating without that process. I mean, as we talked about early in this podcast, I really moved directly from college to Dallas, Texas, working on this facility for 2 years. Um, so, like, I never really spent the time back in the shop going through this process and, you know, making making the calls to fix things and driving the project forward was the only thing that was really on anybody's mind. So coming back to the shop, it felt like, I was firing on all cylinders. I was at the top of my game at that point, and then I suddenly hit a wall. And those 8-hour days back in the shop felt so much worse than the 16-hour days out in the field. Here's the thing about working in a shop environment, and this isn't, I can't go and just blanket apply this to everybody, but at least this is how it worked in the one that I was in. There were engineers who had never been in the field. Like, these were good people. They were smart. They knew their stuff, but their frame of reference was how systems worked in the shop. Their drawings, their calculations, the customer specs. And, one of the things that has been kind of a joke throughout my whole time of doing this podcast is, I talk about in my intro of, how things worked in CAD. And a lot of that mentality is really from this point in time where, we did have a lot of engineers that, you talk to them and you'd be like, hey, this didn't work in the field. And they'd genuinely look at you and be like, well, it worked on my CAD. So, that's it. Again, it's something that you may have noticed in my episodes. There's this overarching theme of, it worked in CAD. But the thing is that I get that when you're designing something, you have to work off of something. So you work with what you're given. But the problem is that the 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 environment that you have in a shop is perfect. When you're looking at something in CAD and you're designing something in CAD, everything is perfect. There is no space in there for imperfections. If I go into CAD and I design a bracket, when I put in that angle for the bend for the bracket, that is a perfect 90-degree angle. It's there is no putting in, oh, you know what, this is a 90-degree bracket, and CAD just magically makes it, something else, an 88-degree angle. It doesn't work like that. It's perfect in CAD. So you never really see that when that part is actually like physically created, that there is differences. There's, maybe it didn't get bent at a perfect 90. Maybe one of your bolt holes got stretched. You know, uh, there's so many different ways that you can run into this, but this is just an example of, like, it doesn't always work in CAD. And one of the concrete examples I'll give you is like conveyor speeds. So one of the most consistent friction points that I ran into was when our mechanical engineers would design a conveyor system and they would pick the gearboxes, set the speeds, all based on calculations. And the calculations weren't wrong necessarily, but the problem is that when you're doing these calculations, a lot of times, at least the way we did it was spreadsheets, and you would punch in what you're trying to do. So if I want like a 10-inch gap between products, uh, there's an equation for that, and it'll tell you what conveyor speed produces that gap. But what the math doesn't tell you is if you actually need like a 10-inch gap, you might need to pull mathematically an 11-inch gap because you're not accounting for all of your slippages. You're not accounting for like how the product itself actually moves down the line. So you don't end up having a perfect model, right? So again, it goes back to, it works in your CAD. You do the same thing with like your conveyor speeds, where if I have a perfect system and I completely disregard all of the different things that could happen, then mathematically I can tell you exactly what speed that motor needs to run at. But again, you're only getting a piece of the system there, and the other stuff that you don't necessarily know when you haven't spent the time on the field is, if I pull that 10-inch gap, what can the caser downstream actually do? What can it handle if I'm throwing a carton with a 10-inch gap into its infeed? Is there enough accumulation upstream to give me enough of a buffer? When that gap closes, do I have too much back pressure? All of that sort of stuff lives in the field and not on paper, not in your CAD. And I had lived through all of this in episode 5, where I spent the days and days merging or on that merge table, and the math said that everything should work out perfectly, and I knew personally that it's not going to be perfect. That was the whole thing that I had to work through, was taking that theoretical knowledge and applying it to a real product is completely different. And then I'd come back to the shop and I watched the same decisions get made the same way that, I started with that merge table of, going through all of the data, going through all the CAD, going through all of, these hard numbers of, what this system should theoretically operate like. And one of the things that always got me was nobody ever asked me as the controls lead for the project what I needed. Nobody said, "Hey, you just spent 2 years on these systems. What actually worked?" And, the part that really killed me with this was, when I did try to bring some of this stuff to the table, the answer was pretty much always some version of, well, mathematically this checks out, so, this is what it's going to be. And it was one of those situations where there was this it was a structural problem within the company. It wasn't necessarily a personnel issue. The people who were there with the decision making authority didn't have the field experience, and the people with the field experience didn't have that decision making authority. So you create this structure where, the field engineers learned to just fix it in the field. And that was kind of always the unspoken agreement. And it sucked. You play the game in the shop, you nod at the drawings, you go through the process. I want to move this photo. Why? Okay, this is where I'm proposing we do it. This is where it goes in the panel. You go through and you do all this stuff, and you play the shop game. Whether or not it actually got approved, you just did it. You pretended like you were part of the team and that you were going to do all this stuff. And then when the system actually got to site and it wasn't working the way that it was supposed to, you made the changes that you tried to get through the process the right way on the front end. You just made those changes on the back end in the field. And the thing is that nobody ever followed up. Nobody nobody would come out to site and say, "Hey, wait a second. We talked about this and we decided no." Once the project left the shop, the only thing that anybody cared about was getting it commissioned, getting sign off, and moving on to the next project. So this cycle just kept going. And again, I want to be fair here. There really were good mechanical engineers in this company. People that really knew their stuff. They saw the same problems that I was seeing, but again, they were in that same position. They didn't have the authority to change the things that needed to be changing, and the structure above them wasn't really interested in being changed. And that part just really it really wore on me. It wasn't just that, the problems existed. It was that I could see what was causing them, and there really was no clear path to fixing it from my position. There was a specific moment that I keep coming back to from that period. So we're doing a debrief on Dallas. I had notes. I always took a bunch of notes when I was out in the field. And they were my personal notes. They were little scribbles of, "Oh, hey, I should do this in the future," or "I need to pay attention to this, this didn't work," or whatever. I was still early enough in my career to actually believe that, that feedback mattered, and if I brought the right information back to the shop, that something would change, and we would improve. I hadn't learned yet that things weren't going to change. uh, and it sounds so negative. And I'm not intentionally being negative, but you know the way that this company was structured, it just wasn't going to change. So here we are. We're sitting in this debrief, and we get to talking about the merge table on line 10. The triple lane merge that we were talking about with the 210 cartons a minute that I spent weeks tuning. The spreadsheet, the math models, the feedback loop that I used to get it all working. We talked about all of it. And the response from the mechanical lead was basically, "You made it more complicated than it needed to be." And I just remember sitting there staring, like I had no words. I had the math, I had the documentation, I had the data showing why the simple approach that they had designed this around wasn't enough. I lived through that problem for weeks, and I knew that system incredibly well. I knew that system probably better than anybody else in that room knew. And I knew why it was more complicated than it looked on paper. And none of that mattered. I didn't argue. I went quiet, which, if you know anything about how I normally operate, is probably a louder signal than anything that I could have said out loud. At this point, I found my voice in the company, and I was saying things that needed to be said. I was bringing up issues. I was trying to genuinely improve the company. And in this meeting, I just sat there quietly. The meeting ended. I went back to my desk, and I left early that day. And it wasn't a dramatic leave. It probably wasn't even noticed, but I looked at the clock. I saw it was 3 o'clock, and I thought, you know what? I'll make up my last hour later this week. I'm just done. I'm out of here for the day. And that was kind of the moment, looking back now, where I understood what the shop politics were going to look like. And it wasn't a place where field experience really got translated into better systems. It was a place where field experience went to basically wait until the next project. I spent about 6 months back in the shop before I was on the road again. And, it sounds like I'm really negative about it. But the thing of it is it wasn't entirely wasted time. There really, truly is a huge, huge value in that front end work. And, there's a value in being part of designing something before it gets out to sight. I learned things during that period of time that made me better in the field. But the, the problem is I also learned something about myself. And, I think that, again, this all really ties back to being a young engineer. And I really figured out during this time that I was a field engineer. And that's where I operated really well. That's where the things that I was really good at, the moving fast, making decisions, living inside that problem until it was solved, actually mattered. It's being out in the field was where, I really got to be the engineer that I felt that I was. And the way the shop was set up really wasn't built for how I worked. And, honestly, at this point in time, I wasn't built for the way that the shop worked either. There's a specific kind of frustration that comes from having done the really hard parts of the projects, like really done it, like fully jumping into something over years uh, with a project and trying to make something work that has some of these front end problems, and then sitting in a room where the people who weren't there tell you that what you did was wrong, or it was too complicated, or you could have just done it this way. That Monday morning quarterback thing. It's just there's so much. It's a very specific frustration, and it's not like anger. It's more like a door closing. And maybe that's what this period was for me. It was a door closing on one idea of how my career was going to be, and beginning to look at a longer process of figuring out what I actually was looking for. I didn't have an answer yet, but I was starting to understand what it was that I was really looking for at this point in my career. And it wasn't the shop, it wasn't the politics. It was in a lot of ways just that raw engineering that happens when you're faced with a problem out in the field. This has been From the Bucket, where controls design meets reality. Until next time.